Hello everyone, I'm Bingja. Welcome back to another video. So in this video, we are going into chapter 8 of the IGCSE maths, that is the probability. So in this video, I'm gonna be sharing about what is generally what is probability. All right, so the title and so all you need to know about probability. So this is number one, we're gonna talk about the properties, and number two, I'm gonna be talking about the expected frequency. All right, but we will see that later on. All right, so what is probability? So probability is the likelihood of something to happen. All right, so let's say if I'm going to flip a coin, so a coin, there are heads and tails, right? So what is the probability that I get tails, right? So if there are only two outcomes, so the probability is just half for each one, so you can get half of a probability, half out of two. I mean, 1/2 probability of getting a tails, right? So for more examples, we're gonna continue on in the video. So this is about probability. So how are we gonna denote the probability? All right, so there are different ways to denote a probability, but the general way to denote a probability is a probability of event A happening, right? Okay, we usually denote as PA. All right, so the P in front means the probability of A happening. All right, so for example, probability of rolling a tree in a die. All right, so what is the probability of rolling a tree in a die? Okay, so we know that in a fair die, okay, we need to say that the die is fair. Okay, fair dice. All right, I think one is plural and one is singular, but okay, so a dice, there are 6 numbers, right? 1, 2, 3, 4, 5, 6. So if it is fair, then we denote as let A be the probability of rolling a tree. All right, so if you let A be this event, so the probability of this event happening, all right, P of A will be equals to 3, all right, out of 6. All right, so it's equals to, sorry, not 3 out of 6, it's 1 out of 6. Yeah, that's a very bad mistake. So it's equals to 1 out of 6. Why is it 1? Okay, so from a dice, all you will see is 1, 2, 3, 4, 5, 6. All right, so there are 6 possible outcomes, right? So if you can see from these 6 possible outcomes, there is only one outcome that gives 3. All right, therefore this is equals to the event, the number of outcomes of the event, right, divided by number of total outcomes. All right, so number of the outcomes of the event happening divided by number of the total outcome. So this is the probability of you rolling a tree in a fair 6-sided dice. All right, so as you can see here, the total for a probability, we denote is from 0 to 1. Okay, so this is 0, 0.5, and 1. All right, so what does this 0 and 1 mean? Okay, so when your probability of A is equals to 0, that means that it is impossible to happen. All right, because what is the probability of you getting a 7 out of a 6-sided dice? It's impossible. Therefore, you will never get the outcome. So it's 0 over 6. Therefore, you get 0. So from 0, we are going to write impossible. Okay. However, if we are going to say a probability of you, okay, I'm going to write down the example too. The example is rolling a 7 from a 6-sided dice. All right. However, if I'm going to say the probability of A is equals to 1, that means it is certain that it will happen. So this is certain that it will happen. So it's definitely going to happen. So what is the example of a certain happening, right? So let me change this color. All right, and write this here. So what can happen in order for you to be certain that it is going to happen? All right, and the very good example that I can think of is still using the dice example, but we're gonna say rolling a number lesser than 7 from a 6-sided die. All right, because we know that a dice only contains 1, 2, 3, 4, 5, 6. So if I'm to tell you I want you to roll a number lesser than 7 from a 6-sided dice, then you are certain that you will definitely get a number lesser than 7. Therefore, this is when the probability is equals to 1. All right, so when it's probability 0.5, this means that it is equal likely. All right, so when can you say that the probability is equal likely to happen? All right, and this is the example that I gave just now. So tossing a coin. All right, e.g. tossing a coin and get tail, because we know there are only 2 faces for a coin, so it's half of the probability of you getting either one of them. All right, so if you are going to the left side of equal likely, then it will be unlikely to happen, followed by highly unlikely. All right, so after you move towards the let me draw the line here and here. Okay, so when you go past the equal likely to the right side, then it will go on to likely and highly likely. All right, so the probability will never pass 1 and never go below 0. All right, so this is the number 1 rule for probability. All right, so I'm gonna write it down here. Okay, I'm gonna write it down here. The probability is always in between 0 and 1. For 0 is impossible and 1 is certain. All right, so this is the number 1 rule that you will have to know for probability. So whenever you say a probability is 1, that means it is definitely going to happen. All right, so from the first slide, after we know all this, all right, we say the probability of A is equals to the outcome, right, the number of outcome that gives A divided by the number of the total outcomes. All right, so from the first slide, we say that we want to get a 3 when we roll a dice. So the number of outcome that gives a 3 is 1, and the total outcome will be 6 because we can get 6 different numbers from rolling that, and therefore the probability is equals to 1 over 6. So if we are to present, okay, this is in a fraction form. All right, so the example from 1 is rolling, okay, rolling a tree in a fair 6-sided dice. All right, then in fraction, the probability of A is equals to 1 over 6. Okay, so in fraction, this is in fraction form. Okay, this is fraction, and if you press the calculator, 1 divided by 6, this is going to give you 0.1667 to 4 significant figures, and this is in decimals. All right, so you can use either way to represent a probability, but usually if the decimal does not give an exact one, we will actually prefer a fraction so that you can get a more accurate answer when you work through your question. All right, however, it all depends on whether the question asks you to present your probability in terms of a decimal or a fraction. Okay, so this is all about this, and there is still another way to present a probability, which is in terms of percentage. So 1 out of 6, you multiply with 100%. All right, if you type it inside your calculator, you will get the answer is equals to 16.67 to 4 significant figures, and this is in percentage form. All right, so the same thing is just how you want to present it. Okay, so it is 16.67% out of 100%. All right, so in percentage, 100% is you're definitely gonna happen. So if you get 100% in your exam, means that you answer everything correctly. If you get 0%, means you did not answer any of the question correctly. So it actually works the same as the probability. So if there's a space down here, yes, I'm gonna draw the difference between percentage. All right, you can go from 0% to 100%, whereas in what is it called, in probability, you will go from 0 all the way to 1, where 1 is certainly gonna happen and 0 is impossible to happen. All right, so this is all about the ways to write the probability, whether it's a fraction, decimals, or percentage. So there's these 3 ways to write a probability of an event happening. Okay, so next we are gonna say a complement. All right, so what is a complement of a probability? Okay, let's write down complement. Complement probability is whatever that goes the opposite meaning of what the event wants. The event will not, okay, occur. Okay, so if we are going to use back the same example, EG1, what is the probability of not getting a tree from rolling a fair dice? All right, a fair 6-sided dice. 6-sided dice. All right, so there are a lot of different ways that you can do it. So in this simple case, we can still actually count. Okay, let B equals to an event that not 3. All right, so you roll something that you do not get a 3. All right, so from a fair 6-sided dice, you will get 1, 2, 3, 4, 5, 6. Right, so in this event B, when you want to get a number which is not 3, you can get 1, 2, 4, 5, 6, which means there are actually the probability of B is equals to 5 out of 6. All right, so the 5 here is the number of times you will get B, and the 6 is the number of the total outcome. All right, so this is how you can get the probability of B. And as you can see, the relation between a normal one and a complement of it is actually A, all right, B is not A. All right, how do I say B is not A, meaning or in other words, okay, the outcomes for A is 3, right? However, for B is everything except 3. All right, so we say B is a complement for A. Therefore, we can denote B as A prime. All right, so what is the relation between A and A prime? So if A is an event happening, then A prime is that event not happening. Then we can say the probability of A prime is equals to 1 minus probability of A. All right, so how do we make sense out of this equation? So 1 is everything that is certain that is gonna happen. So if we're gonna rearrange this, we get PA plus PA prime is equals to 1. So if in the same dice equation, in the same dice example, all right, if you're gonna say A is get 3, all right, and A prime is not get anything except 3. All right, so if you are gonna get out of 1, 2, 3, 4, this is only 1 out of 6. Okay, and this from the slide just now, we get B is probability of B is equals to 5 over 6. All right, so we can add it up, 1 over 6 and 5 over 6, you will get the answer 1. Therefore, this is the relation that you will want to remember. All right, the complement of an event is equals to 1 minus the probability of that event happening. All right, but logically, if it's happening, then the other part is not gonna happen. So if it's certainly gonna happen and you take out the probability that it's going to happen, what's left is the probability that is not going to happen. All right, so hope you get a gist of idea of what this complement means. And this is the formula of a complement. All right, so a complement of an event is equals to the probability of it's certainly going to happen, which is 1, minus out the probability of that event happening, which is the probability of A. All right, so yeah, this is all about this complement thing. All right, complement probability. So next, we are going to go on to expected frequency. All right, so the expectant frequency is technically, how do I say this? Expected frequency. Okay, so the expected frequency is the formula will be, let's write down the formula first. The expected of A, all right, will be equals to the probability of A multiply with the total the sum of the total frequency. Okay, what does this mean? So if I'm going to say the example here will be, let's say I throw a fair six-sided dice, all right, 6 times. How many times will I expect to see a tree? All right, so if you can understand this question, I'm throwing a fair six-sided dice, all right, for 6 times. Okay, so how many times will I expect to see a tree? Okay, so from the previous slides, we said that the probability of us getting a tree is 1 out of 6, because we can get 1, we can get 2, we can get 3, 4, 5, and 6. There are 6 outcomes, and there's only one outcome that includes 3, so it's 1 out of 6. So if I throw this six-sided dice 6 times, how many times will I expect to see a tree? All right, if we are using the formula up there, it will be 1 over 6 multiplied with 6, that is equals to 1. And this means I will expect to see 3 once, right? Because the expected frequency works like if we are going mathematically, all right? So mathematically, 1 out of 6 means every 6 times you will get the result once. Okay, so if you're gonna throw 6 times, all right, and the probability of it happening is 1 out of 6, then it probably means you are gonna see it at least once. Right, so the first throw it might be 2, then the second throw might be 4, and the third throw you will get 3. Okay, and the fourth throw you will get 1, the fifth throw you will get 5, and the sixth throw you will get 6. So out of these 6 throws, you will only get to see 3 once, and this is the expected frequency that you will see an event happening. And however, it is not the same case as an observed frequency. The observed frequency is according to how you throw the dice. All right, so let's say you might get 3, the number 3 maybe 2 times. All right, who knows, because it's every single time you throw a dice, there is an equal 1 out of 6 probability of you getting the number 3. All right, so I hope you guys actually get the little bit of introduction to probability throughout this video. So just as a recap, I believe it's a long one. So the probability you can denote is, and you can denote a probability of an event A by P bracket A, right? And then it will be the number of the outcomes of that event divided by the number of the total outcomes. All right, how you can remember it is, let's say you want this to happen, and out of everything that might happen, all right, so this is the probability, the likelihood of this event you want to happen happening. All right, so I had introduced to you what is the probability of how to denote a probability, and then the probability scale. So from 0 to 1, with 0 is impossible to happen, and 1 is certainly going to happen, and with equal likely being 0.5. All right, so maybe if you see your weather forecast, all right, your weather forecast say the probability of it raining the next hour is very high, right? So the forecast is saying that it is highly likely to rain in the next hour. All right, so this is how the probability going to work, because there is still a little chance that it is not going to rain. All right, so the example I can give here is, all right, let's say forecasts say that the chance of raining in the next hour is 90%. So what are the chances of it not raining in the next hour? Alright, so in this case, it is just either a rain or a not rain situation. So from the example that we see just now, so let A be rain, then A prime will be not rain, right? So we know that the probability of A is 0.9, or if you want to write it as 90% as given in the question, but usually we will write it in the decimal form. Okay, so what is the probability of it not raining? So if it's not raining, right, if it's not raining, then it's probably just everything that is going to happen minus with the probability of it raining, which is equals to 0.1, and it's 10%, right? So the chances of it not raining in the next hour is in fact just 10%, which is, if we refer back to the probability scale here, which is very highly unlikely. So as you can see, this is the reason why they are called complement probability. They complement each other. So it's either if it's happening, then the probability of not happening is equals to 1 minus the probability of it happening. Yeah, so I hope you guys will understand this. And then probability will just be in between 0 and 1, okay, no matter it's in decimals or in fractions. All right, because the fraction, you will never get a probability higher than 1. Okay, so if you get any probability higher than 1, something is wrong with your working. All right, so you need to double check with your working. All right, so I had also introduced to you how to represent a probability out of fraction, decimals, and percentage. All right, it's up to you, but usually we use fractions and decimals more. But just for you to know, there might be a possibility that the exams will give you in terms of percentage. All right, I introduced to you complement probability, and last but not least, the expected frequency. All right, of getting the event, to expect the happening of that event, right? Let's say if I throw a fair coin 3 times, what is the probability that I will get the tails, right? Then that's just probability is 1/2, and I threw 3 times, which is 1.5. So sometimes it might sound a little bit funny saying that I'm gonna expect to see 1.5 times, but yeah, that is the mathematics side of saying that I will see a tails if I throw 3 times is 3 out of 2, right? So yeah, this is basically all for this introduction to probability video. So in the next video, we're gonna look for a lot of ways to present a probability out in a diagram. So yeah, hope you guys enjoy. See you guys next time.